Hey folks, welcome to the NCEA Level 2 probability paper from 2023. If you're joining us for the first time, the way this video works is that I go through each question and let you know what you need to do for achieved merit and excellence. The best way to watch this video is to pause the video at the start of each question, try the question out by yourselves, and then unpause the video just to see how I go about answering the questions. Also, if you haven't subscribed yet, please do subscribe, and of course, share this with your wider networks. So without further ado, let's get started. All right, folks, so with question one, there's actually quite a bit of things to read here. And also they've kind of given us a big probability tree that we need to kind of work through. So one thing I'd recommend is just pausing the video at this point, reading through that, and maybe having this probability tree in a separate page. So we're going to try and kind of fill that probability tree first, because that's what it's asking us to do. And then second thing is, like, once we fill the tree out, then we've got to try and answer all these questions that's going to pop up later on. So looking at this, I guess the first three bullet points here. So 15% of the games, actually let's go with this one, 15% of the games it picks up the toy and drops again. So basically that's what this 15% is, and as you can see, that's 15%, that's going to be 15. So wherever there's a D, that's all going to be 15%. So let's actually do that one first. So we got 0.15, 0.15, because that's pretty much what the question is saying right at the beginning. So we've done all of the first bullet point. Now, if you look at the second bullet point, out of the other attempts, about 1 in 10 games will be selected by the machine. Okay, so that 1 in 10 part is already done as well. That's right at the beginning there. Now it says if the game is not won, then the probability of the next game will change as the remaining random numbers decrease. So probability of the second game being won is 1/9. So that 1/9 is for the victory there. 1/9 is for the victory there, but because it's actually reducing, this is no longer going to be 1/9, but it's going to be 1/8. This is going to be 1/8 and 1/8. So basically, because it's the third turn, it's going to be dropping down to 1/8, and finally this is now going to drop to 1/7. Let's go back and have a look. Yep. So it says on one day, Alex, with this strategy, if she wins a toy, she stops. So wins a toy, she stops. So that's going to be here, here, here. So basically wherever she's winning, that's where she's going to stop. Second point is if it drops, she tries again. So as you can see, dropping, she's trying again. Dropping here, she tries, drop, trying, drop, trying, drop, trying, and we're not trying over there, we're going to get rid of that, and drop, she's also trying. The other thing also is the last bullet point is she keeps playing until she's had 2 losses without it dropping for a maximum of 4 games. So she keeps playing until she had 2 losses. So basically, so as you can see, there's a loss and a loss, she stops. Then this would be loss 1, loss 2. So she could actually have lost, dropped, and loss. Loss, dropped, dropped, and loss. So those are the green points is where she's going to be stopping. I think this is probably the most kind of annoying part of this question, but then the last part that we need to do is we actually need to fill up the remaining probabilities. So particularly I'm looking at this branch here. So to do that, I am going to go we've got 1/9 and 0.5. So I'm going to go 1 minus 0.15 minus 1/9. So that's going to give me 0.7389. So this is 0.7389. That probability is going to repeat here again. And I've got to do the same step again, but this time with, instead of 1/8, it is going to be, 1/9, it's going to be 1/8. That's 0.725. So these 3 branches here are 0.725. And then finally, we're going to do, instead of 1 over 8, we're going to do 1 over 7. And that's going to give us 0.7071, which those branches there. Just realized I actually forgot the 0.15 here as well, which is the dropped. Okay, so we've got all the probabilities now, and I think now we can go and have a look at what is the first question. The first question is, what's the probability that the claw drops on the first game and then Alex wins on the second game she plays? So drops and Alex wins on the so this is dropping and then winning on the second game she plays. So I'm looking at that purple branch there. So the answer is going to be 0.15 multiplied by 1 over 9. And that's going to give me a probability of 0.0167. Just double check that. 0.15 divided by 9. There we go. Yep, 0.1667. So you can actually just have, for achieved grade in this question, you can just write the answer itself. But as always, just get into the habit of writing answers with the working as well. So that's probability correct. Yep. Now let's look at the second question. So second question is, what's the probability Alex wins the third game she plays? Now to win the third game she plays, so I'm going to put this in a different color here. So third game winning in place is 1, 2, and 3. So looking at those 3 branches, so we've got drop, drop, and win. We've got drop, loss, and win. Then at the bottom we've got loss, drop, and win. So we've got those kind of 3 branches that we've got to work with. So the probability of drop, and so drop, drop, win. Then we got the probability of drop, loss, win. Then we've got probability of loss, drop, and then win. So those are the 3 different situations that could happen. So all we have to do is multiply those 3 branches, well, each branch, and then we add up the probabilities. So drop, drop, win is going to be 0.15 multiplied by 0.15 multiplied by 1 over 8. The drop, 0.15. The loss is 0.7389 and multiplied by 1 over 8. The loss is, didn't actually work out the loss there. Okay, let me just do that quickly here. So the loss branch is going to be 1 take away 0.15 take away 0.1. So that's going to be 0.75. 0.75 is this branch here. So I'm going to get 0.75 multiplied by 0.15 and multiplied by 1 over 8. So basically, this actually gives me each of those orange branches, what they are worth. So now I just need to work out what the probability is for each of those branches. So I've got 0.15 times 0.15 times 1 over 8. So that's going to give me this ugly looking thing here. So 0.00281. Then the next one is going to be 0.15 multiplied by 0.7389 multiplied by 1 over 8. And that's giving me 0.01385. Then finally 0.75 times 0.15 times 1 over 8. That's going to give me 0.0. Did I do something wrong here? Oh yeah, 0.014. Sorry, just checking my answers as well. Okay, now we just add up all of these 3 values together. So we've got 0.01 blah 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 plus 0.00281 plus 0.01385. So adding those 3 probabilities, we're going to get, might just say probability of wins third game is the total of that, which is equal to 0.0307. Now grades wise, we're looking at consistent probability without changing p winning to 1 over 1. Correct partial probability is 1. So adding all 3 probabilities gets you a merit, and achieved is going to be getting one of these 3 things correct. All right, so next question is, what is the probability Alex wins the claw game within a maximum of 4 attempts? Now this is a bit of a long-winded question, because For starters, if we go back to the table, I'm going to have to choose a different color here because I think I've exhausted all my colors. Might just get rid of the orange here. And we are looking at a maximum of 4 attempts. So you want to see what are all the possibilities for her to win. So going to this, so we've got to work out like 4 different attempts, right? So she could win with the 4th attempt. So you've got to work out this branch. She could also win with the 3rd attempt. You got to work out these 3 branches. She could also win with the 2nd attempt and then the 1st attempt. So you've got to work out each one of those branches and you've got to add it up together, and that'll give you what's the probability that she actually wins in a maximum of 4 attempts. So super annoying with this. Might actually just work on this side here. Sorry folks, I'm just going to move the question here. So first, looking at probability of winning in the 1st attempt. So winning in the 1st attempt is nice and simple because that's actually 1/10. And that's pretty much this part right here. So we're looking at 1/10. That's actually nice and easy. Now probability of winning in 2, we've actually got 2 branches because we've got probability of she drops it and then wins plus probability of loss and a win. So if we were to do that, we're going to get drop and win, which I'm looking at here. Drop and win is this, loss and win is this. So those 2 branches is what we're doing here. So I'm going to get rid of that. So drop and win is 0.15 times 1/9 plus loss is 0.75 times 1/9. And I might just do this in the calculator straight away. So we've got 0.15 plus 0.75 is 0.9. So 0.9, just do this the long way. So you're going to get 0.1 here as the probability of winning in the 2nd attempt. Now we repeat the step for the 3rd attempt. So probability of winning in the 3rd attempt, I think we already have that. We have that from the previous question that we did. Where was it? 0.0307. So this is what we did for the 3rd one. So I'm not going to actually work it out. I'm just going to use it from that previous question, which was 0.0307. So 0.0307. And then probability of winning it over 4. Now this is when things get a little bit dicey because for winning with 4, we've got to get these branches correct. So we've got D, D, win. D, D, loss, win. We've got loss, D, D, and win. Now we also got drop, loss, drop, win. So that's the 4 branches that you have to add up for winning with on the 4th attempt. So we've got, gonna have to write that down actually, probability of drop, 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 and win plus probability of drop, drop, loss, and a win plus probability of drop, loss, drop, win plus probability of loss, drop, drop, win. So those are those 4 branches that we've got to kind of add up, and we're going to kind of put all those probabilities together. So we've got 0.15 times 0.15 times 0.15 times W, which is 1/7. So that's the first one, plus 0.15 times 0.15 times the loss is 0.725 times 1/7. So that's the second branch. Then we've got the third branch, which is 0.15 times 0.7389 multiplied by a drop, which is 0.15, and multiplied by 1/7. And then the last one, I'm sorry folks, I just have to do it in the next line. So we've got 0.75 times 0.15 times 0.15 times 1/7, and that's the last red branch there. So when we put this all together, probability of 4 items, I need to be very careful about putting this in the calculator so that I don't actually make a mistake. So 0.15 times 0.15 times 0.15 times 1 over 7. That looks correct. Plus 0.15 times 0.15 times 0.725 times 1 over 7 plus 0.15 times 0.7389 times 0.15 times 1 over 7 plus 0.75 times 0.15 times 0.15 times 1 over 7. God, that's painful to enter. And when we do that, we actually end up with 0.7598, or no, actually not. How many is that? -3, so it's going to be 0.007598. Now we've got these 4 probabilities. So then we're going to say probability of max 4 attempts is equal to 1 over 10 plus 0.1 plus 0.0307 plus 0.007598. So I'm going to put that all in the calculator. So I've got 0.1 plus 0.0307. So, and that should give me 0.2383. Long question for this one, but in terms of grades, probability of wins in exactly 4 attempts found 0.706. Okay, so this one here is going to get you a merit grade, and the final answer here is going to get you a T1, which is an excellence grade. Yeah, so it's a bit of an annoying question with that many things happening there, but I'm sorry that I just kind of went on a bit of a highlighter rage there. So yeah, that's part A of this question. And now we go to part B of this question. So I think in the question paper, they did leave some space for you to draw this diagram. So, and I think once we draw the diagram, we'll go and answer these questions below. So firstly, to start off with, Alex goes 70% of the time with her friends. So friends is 0.7. We're going to go 1 take away 0.7 for the 0.3. Then it says if she goes with friends, she plays the claw just once and wins 10% of this time. So if she goes with her friends, she wins just 1% of the time, and she loses 0.9. And then if she's by herself, she plays multiple games and wins on about 1/4 of these visits. So a win is going to be 0.25 and a loss is going to be 0.75. So that's pretty much the rough starting point of this particular probability tree. And if we go to the question, what's the probability of Alex winning the claw games on her visit to the arcade? So for her to win on the arcade, we're looking at winning the claw game. We're looking at this branch plus this branch. So we're going to say probability of winning claw is 0.7 times 0.1 plus 0.3 times 0.25. And again, putting this in the calculator. So 0.7 times 0.1 plus 0.3 times 0.25. That it gets 0.145. And that's pretty much it for this question to get an achieved. Now, the second part of the question is, I'm going to actually try and move this up here so we can continue working with the probability tree, and then we can try and work it out. All right, so the second part of the question is we've got an extension to this question. So after playing at the arcade, so still working with the same rules here, but it says if she loses the claw game but is with her friends, she is 3 times more likely to buy a treat from the cafe than she was by herself. So let's say that when she loses, she gets a treat at the cafe, but it's going to be 3 times more than what it was when she was by herself. So if you look at it, if this probability is X, because we don't know what that probability is, but whatever it is, it's going to be 3 times more if she is with her friends. But it says if Alex wins the claw game, she's twice as likely to buy a treat from the cafe than if she is with her friends or not. So if Alex wins the claw game, she's twice as likely to buy a treat from the cafe. Right, so it actually says it's twice as likely to buy it than if she loses. And so if she loses by herself, then it's going to be X. Now X times 2 is going to be 2X because it's twice as likely. And then when she's with her mates, it'll become 3X times 2, which will become 6X. So that's for a treat at the cafe. As for the no treat, we don't really have to worry too much about it. We're just going to kind of ignore it in this case, because the question says find the probability that on a random visit Alex wins the claw game and buys a treat. But it says the probability that Alex buys a treat overall is 40%. So basically this 40% represents this branch, this one, and this one. So it's 4 branches that we have to keep in mind, and all those 4 branches add up to 40%. So let's actually work that out first. So we're going to get 0.7 times 0.1 times 6x, and then we've got plus 0.7 times 0.9 times 3x plus 0.3 times 0.25 times 2x plus 0.3 times 0.75 times x. Now all of this is equal to 40%, which is the same thing as saying 0.4. So now we need to kind of put all of this together. So we've got 0.7 times 0.1 times 6. That's going to be 0.42x plus 0.7 times 0.9 times 3, which is 1.89x. Then we've got 0.3 times 0.25 times 2. That's going to give you 0.15x. And then we've got 0.3 times 0.75, which is 0.225x. All of this is equal to 0.40. So now we add up all of these numbers up together. So we've got 0.42 plus 1.89 plus 0.15 plus 0.225, and that is 2.685x, and that's equal to 0.40. Now you can just take the 2.685 to the other side and you're dividing it, and then you should actually get what x is equal to. So 0.4 divided by answer, divided by answer, shift, there we go. That should give me 0.1489 as the value for x. So, but we haven't actually answered the question yet, because the question's actually asking us to find that on a random visit with her friends, Alex wins the claw game and buys a treat from the cafe. So we're looking at basically this branch here that we need to work out. So the probability with friends, wins and buys a treat is 0.7 times 0.1 times 6 times x. Now x is 0.1489, and we just have to do that. So we're going to go multiply the probability here by 6, multiply by 0.7, multiply by 0.1, and that's going to give us 0.063. So lovely question actually, but it's actually not too bad. But I think that the trick part is getting the x and 2x right, and I think once you get that right, you pretty much it's a bit of a walk in the park there. So grades wise, correct answer for either x or probability is achieved. So getting this could be achieved, but that's only if you put the answer only, right? But if you do set up the equation correctly, and if you show the x, 2x, and x on the tree correctly, you could get a merit. And then for T1 is one algebraic error in the setup. So you could potentially make a mistake in somewhere here, which could still get you a T1 for correct x value. I think this achieved is only if you do a correct answer only, but if you show all the working, then you could potentially be looking at a T1. And then finally, the final answer there is going to be a T2, which is kind of like excellence. Another excellence grade right there. Right, that pretty much is a very long explanation, but that's question 1 done. All right, on to question 2 now. With question 2, take a moment to pause this video and just kind of read through it, because I'm just going to go through the questions straight away. All right, so part 1, find the probability that a randomly chosen participant is New Zealand youth who watched a streaming service the day before. New Zealand youth watched streaming service. So totally, we've got 1,420. That's the random survey participant. And then we've got New Zealand youth who watched streaming service. So that's going to be 191 out of 1420, and whatever that probability is. So that's going to give us 0.1345. And we might just write something like this: probability of New Zealand youth and streaming, just to keep people happy. So that's going to be worth an achieved grade. Then we're going to go to part 2 of this question. So part 2 of this question, I'm just going to have to move this up a little bit. So get rid of all these parts because we've done that part A. Part 2 is like looking at the table. More adults watch online videos than youth. So this means adults are more likely to watch online. Is this correct? Okay, so let's have a look at the probabilities first. First off, it says more adults watch online videos. So if we look at the total, like how many adults that there are, so there's 1,169 adults, and out of that 1,169, 610 are actually watching online videos. But compared to the kids, youth, it's 251 and 228. So we've got to work out those two probabilities first. So probability of online and youth, online if youth. So watching online, given that they are youth, is going to be 228 out of 251. Then we've got probability of online, given that they are an adult. That's going to be 610 out of 1169. So if we look at the two probabilities, we've got 228 out of 251. That's going to give us 0.908. Then we've got 610 out of 1169. That's going to give us 0.522. Now, what is it saying? Adults in New Zealand are more likely to watch online videos than youth. So I would actually say it's incorrect, because if you look at the actual probabilities, the youth probability is way more higher compared to the adults. So therefore, you kind of say, you just have to kind of mention that. Is incorrect. It's probably looking at the actual number of people and not looking at it as a proportion. So we can say as he is only looking at the raw numbers and not probability. And then we can also say youths are more likely to watch online compared to more than adults because of that proportion there. So we might just say youth are more likely to watch online than adults, because 0.908 is actually greater than 0.522. So grades for this question: one correct conditional probability is worth an achieved. So you might get an achieved for this or this, depending which one you get it correct. And if you have both probabilities correct and you write a conclusion, you are looking at a merit for this question. All right, let's go to part 3 of this question. All right, so part 3 is we've got report to daily reach. Okay, overall percentages. So basically we've got to look at online video. How many out of 1420? Streaming services, how many out of 1420? TV is out of 1420, because these are all overall percentages. So we're just going to go back to the table and look at the online video first. Online video altogether was 838, streaming was 724, TV was 795. Let me see if I can remember that. Online is 838. No, I can't remember. 724 and 795. Now it is asking as a percentage. So what we want to do is we want to actually make sure that we give these in percentages. So 838 out of 1420 multiplied by 100, that's going to give us 59%. Then I got 724 out of 1420 multiplied by 100, that's going to give 50.98, so it's probably 51%. And then 795 over 1420 times, we're going to get 56%. So this question here is worth just an achieved, I believe. Yep, just a straightforward achieved. All right, part 4 of this question. All right, part 4 of this question, what we've got is we've got a report that claims New Zealand youth are about 70% more likely to watch streaming services, but 40% less likely to watch TV than New Zealand, okay, age 25 and over. All right, so we've got a bunch of things that we need to calculate first. So the first thing we need to work out is the probability of streaming if you are New Zealand youth. So probability streaming if you are New Zealand youth. So that's going to be streaming 191 out of 251, which I'm going to work out fairly quickly because it's just like 191 out of 251, 0.7610. Next is we're looking at streaming given you're an adult. So that's going to be, what is it? Streaming 533 out of 1169. So we're looking at streaming an adult. Sorry, I should have put that here. Streaming and youth. So we got 533 over 1169, and that is for no, not TV. So what are we going to be? We got 533 divided by 1169. So that's 0.4559. All right, so the first part is it says New Zealand youth are about 70% more likely to watch streaming services. So the first part, we're going to compare that, which is the relative risk of this. So we're going to go, so the relative risk of the youth over adults. So that's going to give us 0.7610 divided by 0.4559. Now when we do this, 0.7610 divided by 0.4559, we are getting roughly 1.67 or 669. Now, if you look at this, this is basically saying that it's about 66.9% because it's actually above 1. And the claim is that like it's 70%. So you can kind of say that, you know, I'm just going to round that up to like 1.67. 1.67 times indicates that youth are 67%, which is nearly 70% more likely to stream than adults. So that's kind of like the first part there. I mean, you can kind of say it's close to 70%. And because the statement actually says it's about 70%. Now, again, we've got to do the same thing, but we've got to actually do this for the TV. So what we're going to do is probability of TV given that you're youth. So TV given your youth is 228 out of, wait, hang on. I'm looking at online video. TV is 90 out of 251. And that's going to give us 0.3586. Then I've got to work out, sorry, that's the TV and the youth. Then I've got to work out probability of TV given that they're adults. And that one is going to be 705 out of 1169. And that's giving us 0.6031. So if we work out the relative risk for this one, about 40% less likely to watch. So let's do that. So we're going to put the relative risk again. And we're going to do youth over adults. So we're going to get 0.3586 divided by 0.6031. And what we're getting here is 0.5945. Now this is actually close to 0.6. And remember, like it's the opposite way of it, right? So if you think about it, it's indicating that they are 40% less likely. So that's that. Because in the previous question we got 1.67, so that's actually 67% more. In this case, it's actually less than 1, but it's actually less. It's less by 0.4, because this is roughly 0.6, right? So that means we can kind of say it's about 40%. So 0.4 is the less likely to watch compared to adults. So we can say that we're going to say 0.6 times is same as 0.4, or 40% less likely for youths to watch TV than adults. It's very similar to, if you remember, when we're doing increasing and decreasing by percentages. So when you decrease by percentage, you know, you'd multiply, like if you decrease by 20%, you'd multiply by 0.8. That's because of that 20% difference. And that's what's happening here. There's a 60% kind of like, not reduction, but it's the relative risk is 60%, which means we can kind of say that it's actually 40% less likely. So it's the other way. So in terms of both of these claims, so we're just going to say, therefore, both claims are valid. And I think this is important to say, particularly in this question here. So grades wise, lots of possibilities for you to get achieved. So an achieved could come from any one of these probabilities. Merit is finding one relative risk, either this one or this one. For excellence 1, you have to get, so for E, you have to get both relative risks, and then E2, you actually have to do this part right here. That's to get that extra E8 points. All right, let's go to the next question. So with this question, what we've got is how much higher is the percentage of New Zealand youth who watch streaming services in 2022 than it was in 2016. So first off, probability of streaming in 2016 was 102 out of 249. I've got my calculators gone, which is 0.4096. Then probability of streaming in 2022 is 473 out of 706. That's going to give me 0.6700. Now, this question is, it's only asking how much higher is the percentage of New Zealand youth. So it's not asking about any kind of relative risk or not. So in this case, we're just going to go 0.6700 minus 0.4096. And you should end up with 0.2604. So we can pretty much say that the percentage of youth watching streaming services in 2022 has 26% higher compared to 2016. So percentage of youth streaming in 2022 is 26% higher compared to 2016. So really important that you read the question properly for this, because I think correct difference in percentages found. This is only an achieved question. And they're definitely saying in the answer schedule, do not accept relative risk, which is, just want to show you here. Yeah, so they're definitely saying that don't use relative risk at all. All right, so let's go to the second part of this question here. So second part of the question is, I might just have to move this again. Okay, now the second part of the question says, if 400 youth were surveyed in 2023, approximately how many would you expect to watch streaming services? Justify your answer based on one calculation above. All right, so let's have a look at the last kind of 3 years just to see what's actually happened there. Now we got 400 students that were surveyed in 2023. Now if those 400 students were surveyed in like 2022, what would we actually expect? And then we can kind of work out from there. So first, I'm going to work out what's happening in 2022. In 2022, I've got 473 out of 706 kids that are watching, that are streaming. So that's going to be 473 out of 706. And if I multiply this by 400, then this is going to give me my expected value. So that means I'm going to get 473 divided by 706 multiplied by 400. So that's going to give me roughly 268 that are actually watching streaming services. Next, if I look at 2021, I can do 191 out of 251 times, again, 400 students. So 191 over 251 multiplied by 400, that's going to give me roughly 304 students. And then if I look at 2020, I've got 181 out of 262 times 400. So 181 divided by 262 times 400, that's going to give me roughly 276 students. So basically all I've worked out is I might just put them, all of these here, as expected students for each year. And then based on this, I've got to come up with a value, right? So in this, the answer schedule, they're actually saying that you can justify that because there's a drop from 2021 to 2022, your 2023 predicted numbers could be lower than that. So they're saying 2023 could be lower as there is a drop from 21 to 2022. The other thing also is that you could potentially also have a rise. Or 2023 could be similar to 2021. So I think it's whatever you decide, you've got to give a justification and you've got to give a number. You've got to give a whole number for this. So I might I'm just going to go to the answer schedule to show you folks. So as you can see, you can justify it that because there's a drop from 2021 to 2022, so you could actually expect the numbers to be lower, or you could have it returning back to 2021, but as long as your final number is somewhere between 230 and 320, I think you will actually walk away with the grades required. So for me, in this case, I probably would have gone around the 240 mark, just because that there's actually a drop. But also, if you think about it, no, I lie. I actually lie, because this is streaming services. I actually feel like it would actually increase. So I'll probably be a lot more comfortable with the 2021 numbers, because in 2021, there was quite we had the end of the lockdown that was happening, and now there's much more streaming services that are offered. So you can come up with like multiple reasons. You could come up with the reasons that like kids might not want to pay for streaming services, so they might be watching things other ways. Or you might say that, it has increased because they are actually paying for it. So whichever way you say it, just make sure you justify and make sure you give a whole number for the answer as well. Now, grades-wise, we're looking at grades-wise for this question. One expected value found from table for any year. So any one of these three values could be achieved, or at least two probabilities calculated. Now, I kind of skipped the step there, but we do need an expected value for 2023 and an assumption as well. And it has to be a whole number. So it doesn't matter which way you go with, whether you go under or over, just make sure you justify the answer. Fantastic. That's question 2 there, folks. All right, so now we're off to question 3. So with question 3, firstly, we've got normal distribution, kind of putting this really quickly here. So the mean has been given with, what is the mean? 113, and then the standard deviation is 35. And we're looking for probability of X less than 92. I guess we can just put this straight into the calculator. All right, folks, so we're gonna click on the calculator, main menu of the calculator, go into stat mode, and then we're gonna go into distribution, normal. I'm gonna click on NCD, change the data to variable. Now the lower in this case is, I don't know, maybe negative infinity. Just gonna chuck something like that. And then upper is 92. Now the standard deviation is 35 and the mean is 113. And when I do this, I actually get probability. I'm just gonna write the Z value there just because it's always a good idea. Z is less than negative 0.6. And then finally, I'm gonna get 0.2743. And then this question is worth and achieved. Going to part 2 of this question, we're looking at between 2 hours and 3 hours. So probability of 120 minutes and 180 minutes. And so what we're going to do is we're just going to go back and change our two upper and lower limits. So this is going to be 120 and this is going to be 180. And what we end up with is probability of lower and upper. So we're going to put low is going to be 0.2 between Z is 1.91. And then this is equal to 0.3929. And this is actually worth an achieved grade as well. Good starting points here. Right, next what we have got is still working with the same questions. So our mean is still at 113 and standard deviation is, oh no, it's changed now. So in the same studies, New Zealand youth were reported to watch online videos 94 minutes on average, and then we've got 30 minutes of standard deviation. Find the interquartile range. So we want to look for the middle 50%. Now the thing about this question is that you can actually do this in the graphics calculator and you'll get the answer straight away. But if you put just the answer, you are only going to get an achieved grade for it, right? Correct answer only gets you an achieved. So I'm going to show you how to do that anyway. So we're going to go into distribution and we're going to go back to normal and we're going to click on inverse normal. And what I've done here is I'm going to go down to the tail because we want 50%. So it's 25% up and down because that's the interquartile range. We're going to put central and we're going to put the area as 0.5. Then we need to put the standard deviation as 30 and mean as 94. We click on EXE and basically that's going to give us the two values that we need for the interquartile range. Now if you put just these two values, you're only going to get an achieved. But the way we're going to do this is we will have to kind of do this the long way. So to start off, we know that we've got one value, we don't know what that x1 value is. And then from there, we've got an x2 value and all of that is equal to 0.5. So the way it works is something like this. We've got 0.25 here and 0.25 here. Now, if we figure out what the Z1 value and the Z2 value is, then we should be able to kind of rewrite this. And the way we're going to figure out the Z1 and Z2 value is still using the inverse normal stuff, but except our standard deviation is going to be 1 and our mean is going to be 0. So when we do this, we are going to get our two Z values. So Z2 here is going to be negative 0.674 and then Z1 is going to be 0.674. So because we have the Z values, we can remember that we can actually do this. Z is equal to x minus mu over theta. So for each of the Z values, I need to do this. So I'm going to go negative 0.674 equals x minus mu, which is 94, divided by standard deviation of 30. And as for the other one, I'm going to get 0.674 equals x minus 94 divided by 30. Now, if you're worried about like, oh, but my algebra is really not that strong, don't stress too much, because what you can do is you can kind of go into equation, go into solver, and then you should be able to just punch in these values. So I'm going to put a negative 0.674 and I'm going to put that equals, and I'm going to have a fraction, and in the top line I'm going to have alpha x, no, not alpha a, I'm just going to have x minus 94, and then in the denominator I need to have 30. And then I'm going to click on solve now. So that's going to give me 73 so in this case I'm going to get x equals to 73.8. So this is my x2 value, and then my x1 value, I just have to click on repeat, go back there, and then get rid of that minus, and I'm going to get 114.2. Now if you remember, when we did this with the stat mode, I think we got those same answers. So distribution, normal, inverse normal, our standard deviation was 30 and 94 was the mean. And as you can see, we're getting that 73.76, well, 73.8 and 114.2 as our two values there. So this is pretty much our interquartile range. So if you look at the interquartile range, because that's what it's asking for. The interquartile range is 114.2, take away 73.8. So 114.2, take away 73.8. That's going to give an interquartile range of 40.4. And that's pretty much it. I think we've done the IQR, both quantile, interpret, and context. So we probably have to write just a quick little statement to say middle 50% of youth spend between 73.8 and 114.2 minutes watching online videos. So grades wise, we are looking at, you have to show full kind of working to get a merit question. So correct IQR or both quartiles found. Yeah, so you could actually get merit for either this or actually writing a statement. Now, if you had written just the answers, then you will only get achieved there. Or even if you just put like without any working. So you've got to show working for this particular type of question. All right, next one. So we've got, out of 50 New Zealand youth, how many respondents would you expect to spend over 120 minutes watching streaming and online videos? All right, so what we've got to do is we've got to actually work out first streaming services first, and then online videos, and then we can actually try and kind of work it out. So first we're going to look at the streaming ones, because for the streaming one, we want to find out what's the probability they watch more than 120 minutes. Then we have online one, probability of watching over 120 minutes. Now the mean in the original part of it, I think was 113 and 35. Standard deviation was 35. This one was 94 and 30. Yeah, 94 and 30. So first we're going to work out the probability. So probability of x greater than 120 in this case. We're going to go into the calculator, go into menu, go into the stat mode, distribution, normal, NCD. Our lower is 120. Our upper is a very large number. Standard deviation is 35 and 113 is that, and that's going to give us a probability of 0.4207. Now I'm just going to write the Z value. So the Z value has to be bigger than 0.2, which equals to 0.427. Now I want to do the same thing, but I want to do it for the online one. So that's going to be 30 and 94. And when I do that, so I've got probability of x greater than 120, probability of z greater than 0.866, which is equal to 0.1931. So at the moment, what I have is the probability. So I need to figure out how many of these students are going to be over. So to find the expected number, I'm going to go 0.4207 times 50. And then here, 0.1931 times 50. So going back to my main mode here, so I've got 0.4207 times 50. So that's giving me about 21 students. And then next one is 0.1931 times 50. That's going to give me around 9.6. So I'm probably going to round that up to 10 students. So if we look at the difference between the two, because how many more respondents would you expect to have spent watching streaming services online? So you can actually say 21 take away 10, which is equal to 11. So you can kind of say would expect 11 or 12 more youth to have spent over 120 minutes watching streaming, or should I say watching streaming services, than watching online. So grades wise, again, we are looking at one probability found, one expected value found, or correct answer is going to get you an achieved. A merit is you have to do this part here for merit. So you have to find the difference, and it has to be a whole number, and just finishing off with some sort of explanation. All right, next question. Now, for this part, there's like multiple kind of answers. Now, I think one thing that I'm absolutely sure about is that this is not going to be normal distribution. If you think about it, like when I think about streaming or online videos, I think most kids like it ends up being, it can't be a bell curve. Like a normal distribution looks like this, right? You can't tell me that all the kids are watching like this right now. Just looking at the habits of kids at the moment, I know that there is probably a very large contingent of kids that actually watch a lot more towards that high end compared to the low end. And of course, there might be some kids who have like really strict parents who kind of like not really watch as much. So what I would say is like, and I guess I like the way this question's kind of asked to talk about this with diagrams, because you could also end up with like a little spike here and then a big spike here, because this part here could mean that you've got a bunch of kids that are actually not watching as much as their peers are. And then of course there's the possibility of like, if you're watching streaming and if you're watching episodes come in like 30 or 60 minutes. So you might actually end up with like little clumps. So where some people watch 30 minutes and then some people watch like 60 minutes. So again, that's probably why you wouldn't actually use this as why normal distribution might not be appropriate. So you could talk about like how all of these, like normal distribution has to be symmetrical, and these are all the reasons why it doesn't end up being symmetrical. Like here you could have kids not watching as much. Here kids watching episodes of 30 or 60 minute episodes. Here lots of streaming, so quite skewed. So yeah, so I think it's just, you have to kind of write about this, but then just use the graphs as an example, and then you should be kind of good to go. Like in grades wise, I think for this question, one valid reason, one context gives you like an achieved. So one of these reasons gives you an achieved, two reason gives you a merit. I would actually just use your experience. I mean, like you guys know, especially with online videos, that how much time you spend watching. I know that my child struggles with that, and I know he probably ends up being in that high end there. But I also know that there are parents that are quite strict with what their kids are watching. So you might get that third situation happening where there's a large number of kids that are just watching quite less and then not really watching. So that's pretty much, it's just, you just have to write it as how you see it. Cool. Next question. So with this question, I think, if you look at it, the daily average is only 34 minutes of TV, but when you exclude those that didn't watch TV at all, the average is a lot more higher. Now, because there's a large number of kids that don't actually watch TV, that would have actually had an impact on the mean and the median. And that means it could actually cause like a bimodal, or it could actually create like a skewed distribution. And that's pretty much the effect that's actually happening here. So the thing that we need to keep in mind is that like if they're not watching TV, so not watching TV means they'll probably have like 0 minutes, will have an effect on the mean and median. And of course that would change the distribution as well. That would change causing it'll cause like a bimodal one or a skewed distribution as well. So it's just, this question just asking for what happens to the distribution, that's all. So grades wise, this is just a correct answer. This valid discussion in part 1 and okay, so there's one of these double questions. So you have to do this correctly. This is such a weird answer schedule. I think you have to do this correctly to get a start off with a merit, but you have to do and something else for part 2 of this question. So it's a 2-part question. So the second part is assuming normal distribution with mean of 114, 12% of kids do not watch more than 150 daily. So we basically got probability of X greater than 150 is equal to 0.12. Now our mean is 114, and the question is asking what is the standard deviation. So basically with the standard deviation, we've got to find the Z value first. So we're going to put it in like this. So we've got 150 here. All of that is equal to 0.12. We need to find the Z value first. So we're going to go into the calculator, we're going to go into menu, go into stat mode, distribution, normal, inverse. So the tail is going to be right side, 0.2. Standard deviation, we don't know. Now here's the thing. The reason why we're doing inverse normal is because we want to actually figure out what the Z value is. So we're going to go into 1 and 0 and then work it out as 0.8416. Might actually, I'm trying to think, is this right side, left side? Did I put 0.12 or 0.2? Ah, there we go, 0.2. 0.12, let's try that again. Okay, that's much better. So what we've got here is Z is greater than 1.175. So that's the value. So when that happens, it's 0.12. So because our Z is equal to X minus mu over standard deviation, we're going to get 1.175 equals X, which is 150, minus the mean, which is 114, divided by standard deviation. So cross multiply, we're going to get standard deviation is 150 divided by 150 minus 114 divided by 1.175. So we're going to get 1, that's going to be 36. 36 divided by 1.175. And we're going to get a standard deviation of 30.6 minutes. Now grades wise, if you do correct answer only, you are only going to get achieved for this. Correct answer only. That means like not doing any work, just plugging it in the calculator. Correct Z score, again, if you just put the correct answer, you're only going to get achieved. And then, but if you show all the with valid working, so if you show the working, so where was this? This is going back to the previous question. So for the merit and the Z score, which is somewhere here, if you were to do that, you would get a merit. But a correct standard deviation with valid working gets you, with all the working correctly, you're going to get an excellence 1. An excellence 2 is getting this and this statement right is going to give you 8 points there. Now the other thing also is that this particular paper, as you can see, for an excellence you need 20 points. Merit's only 14. That's quite surprised that that's actually quite low for that. Normally merits are like 15 at least. But folks, that's pretty much question 3 there. All right, folks, apologies about the long video. There was a lot of explanations to do in that particular video. If you have any questions, drop it in the comment section below. Yeah, the usual. Good luck for your exams and don't leave any questions empty. All the best. Hey guys, that is basically it for this video. As always, don't forget to like this video, share this video, and of course subscribe to keep up with the latest content. There should be some playlists popping up. Check them out. Great revision material. And as always, thank you for watching.